Earthquakes. These natural phenomena remind us that our planet is a dynamic and ever-changing place. They are powerful events that can shake the ground beneath our feet, sometimes with little warning. But what exactly causes these tremors that can be felt across vast distances? Earthquakes are the result of the movement of massive pieces of the Earth's outermost layer, known as tectonic plates. These plates are in constant motion, albeit very slow, and interact with each other in various ways. When these interactions involve a sudden release of built-up energy, the ground shakes, resulting in what we experience as an earthquake. The study of earthquakes is crucial for understanding our planet's dynamics and mitigating the risks associated with these powerful events. By delving deeper into the science behind earthquakes, we gain valuable insights into the forces that shape the Earth's surface and how we can better prepare for their impact. To understand earthquakes, we must first journey to the heart of our planet. The Earth is not a solid, uniform sphere but is composed of distinct layers, each with its unique properties. At its center lies the core, a sphere of iron and nickel, with a solid inner core and a molten outer core. Surrounding the core is the mantle, a thick layer of hot, dense rock that behaves like a very viscous fluid over geological timescales. The outermost layer is the crust, a thin rocky shell that forms the Earth's surface. It is within the crust and the uppermost part of the mantle, known as the lithosphere, that tectonic plates are found. Imagine the Earth's lithosphere as a giant jigsaw puzzle, with each piece representing a tectonic plate. These plates are not stationary. They constantly move and interact with each other, driven by the heat emanating from the Earth's interior. These interactions are the driving force behind earthquakes. Tectonic plates move slowly but relentlessly, typically at a rate of a few centimeters per year. This movement is not always smooth. When plates push against each other, slide past one another, or pull apart, immense pressure builds up along their boundaries, known as faults. Faults are fractures in the Earth's crust, where rocks have moved past each other. There are different types of faults, each associated with a specific type of plate movement. For instance, at convergent boundaries, where plates collide, one plate may slide beneath the other in a process called subduction. This often results in deep trenches in the ocean floor and powerful earthquakes. At divergent boundaries, plates move apart from each other, creating new crustal material as magma rises from the mantle. This process is responsible for the formation of mid-ocean ridges and rift valleys. Transform boundaries, on the other hand, occur where plates slide horizontally past each other. The San Andreas Fault in California is a prime example of a transform boundary. Section 4. Energy unleashed, the cause of earthquakes. As tectonic plates move and interact at their boundaries, stress accumulates along faults. Rocks are elastic to some extent, so they can deform under stress. However, there's a limit to how much stress they can withstand. When the stress exceeds the strength of the rocks along a fault, a sudden rupture occurs. This rupture releases a tremendous amount of energy in the form of seismic waves, which radiate outwards from the point of rupture, known as the focus or hypocenter, in all directions. These seismic waves travel through the Earth's interior and across its surface, causing the ground to shake. The point on the Earth's surface directly above the focus is called the epicenter. The intensity of shaking is usually highest at the epicenter and decreases with distance from it. The magnitude of an earthquake, a measure of the energy released, is determined by measuring the amplitude of seismic waves recorded by seismographs. Section 5. The Earth trembles. Effects of earthquakes. The effects of earthquakes can be devastating depending on their magnitude, depth, distance from populated areas, and local geological conditions. Ground shaking is the most immediate and obvious effect, causing buildings, bridges, and other structures to sway or collapse. Earthquakes can also trigger secondary hazards such as landslides, tsunamis, and liquefaction. Landslides occur when unstable slopes fail due to ground shaking, while tsunamis are giant waves generated by earthquakes that occur underwater. Liquefaction happens when water-saturated soils lose their strength and behave like a liquid, causing buildings to sink or tilt. The impact of earthquakes on human societies can be profound, leading to loss of life, injuries, displacement, and economic disruption. Understanding the science behind earthquakes is crucial for developing effective mitigation strategies such as building codes, early warning systems, and public education programs to reduce the risks associated with these powerful natural events.